generate descriptive statistics with the describeC function. The one required argument, x, is set equal to the variable to be described or set equal to a list of variables to be described. The describeC function has a standard set of optional arguments. You have options to specify observation weights, the dataset name, the number of digits you want to see after decimal points, and whether you want to print the table of descriptive statistics to an HTML file in your working directory. To see how it's done, let's work through some examples. Let's start with the very basic use of the describeC function for descriptive statistics. I'm obviously running an RStudio session here. I've installed the package, and the only thing I did before starting the video capture was to run the library command to get it loaded in the current session. For reference, you could run describeC, and you should get the technical, there we go, the technical information in the help window, and my configuration is appearing in the lower right here. It could be different on yours, but that'll show the user statement, the arguments, and I'll refer to that occasionally in the video. And I think as you're using a function, it can be helpful to have that on the screen to see it. So to use the describeC function, you type the name of the function, describeC, and it's all lowercase, describe. All lowercase with a capital C on the end, and then like any function, you have a parentheses, and RStudio is kind enough to give us the close parentheses automatically and put the cursor in the middle where we're going to type the value supplied to the function. The only required argument to this function is x, and x is a variable or list of variables that we want to describe, and probably the simplest way to call it would be to describeC in parentheses x, and x is set equal to a variable to be described. For example, in the NES dataset, which is included in the RCPA3 package, has a number of variables, and one of them is called address years. Number of years the respondents have lived at their current address. If I run this in the console, I get a table of descriptive statistics. There is the heading descriptive statistics. Table's caption descriptive statistics for NES $address.years, and you can see a table with a number of rows of items of information about this variable in the data set. It's telling us, for example, that there are 8,119 observed values, and it reports things like the number of missing values in unique cases, the class of the variable, which is akin to the level of measurement, has different measures of central tendency, different measures of dispersion, and even measures of exotic characteristics of the variable, such as its skewness and its kurtosis. So that's the basic use of describeC. If I want to describe a different variable, I could stick with the NES dataset, put my $ again, and if I switch to a different variable, say agree facts, and run it, I get a descriptive statistics, table of descriptive statistics for the NES variable agree facts. Now what you might notice is the table is a lot shorter now. There are 6 rows now. The data set, because this variable agree facts is ordinal level, for the R classifications considered an order factor, there are fewer descriptive statistics to report. So the table automatically is shortened, and the function adapts to the level of measurement of the variable it's describing. And you can't describe the mean or the skewness or kurtosis or variance or standard deviation of the agree facts variable. What you can get is its median and its mode, which are reported by the describeC function. So that's the basic use of the function. So now the optional arguments of the describeC function. I went back to the earliest example, the first example of descriptive statistics, describeC function of the address, description of the address years variable in the NES dataset, and you can see that in the console now. And I've got the required argument x set equal to NES address years. So how do I use the optional arguments? One optional argument is W. And W is an option to weight observations according to sampling weights, and this can make survey data in particular, more nationally representative or more akin to a simple random sample. And then the NES data happen to know that the variable is WT. So if I put a comma, then W equals NES $ WT and run it, I'll get a new table of descriptive statistics. It's pretty similar to the initial table of descriptive statistics, but if you look closely, you can see that some of the variables or some of the statistics reported are a little bit different. For example, the mean with unweighted observations, or equally weighted observations, I should say, is a little over 12, and when the observations are weighted for a more representative results, I see that the mean is a little bit under 12. So that's kind of interesting. Not a radical difference, but these descriptive statistics, which are more likely to be representative of the population of the whole. So since that weight observation is available and easy to use, I would recommend using it in most applications. Other options, one is called data. Another optional argument is called data, and this can be used to name the data set that you're working with. And if you do that, say I say data equals NES, then when I set the value of the X argument or set the value of the W argument, I can simply use the variable name, and the function will know to look for those variables in the data NES. If I run that, I'll get the same results as before. You might notice that the caption is slightly shorter because the variables are just described by name without the use of NES included in there. And I think the use of the data tag, data argument, is somewhat a matter of personal preference. I think maybe it's a little easier to understand this command looking at it, where the data is identified separately than the variables within the data set. It can be a bit shorter, particularly if you're using a function that has multiple variables called, and there can be some advanced applications, like if you subset your data. I wouldn't worry about that now, but I actually prefer not using the data tag in most function calls, because RStudio, if you use like NES $, it will automatically prompt you to pick a variable from a pull-down list. You saw that before, and I think that's very convenient. Makes using the functions a lot easier and reduces the number of typos. But want to be thorough here and discuss all the options of the describeC function. Another option is argument called digits, and digits can be used to change the default number of numbers reported after decimal places. By default, it's 3. You can see that in the usage statement, digit equals 3, but this can be overridden if I want more or fewer numbers reported after the decimal point. So if I change it to SI digits equals 2 and run it, I'll get the table of descriptive statistics with the statistics reported to 2 decimal places. Occasionally you'll get only 1. That means that the trailing number is actually 0, and the trailing 0 is being left off by R. But the fewer decimal places is a little bit less precise, but it can make tables an awful lot more readable and compact, so that can be a very useful optional argument. Finally, we have this argument print C, print capital C, and by default this is set equal to false, but I can set the print C argument of the describeC function equal to true if I want the table of descriptive statistics printed to an HTML file in my working directory. So I will give that a run. And after outputting the table, it gives us this notes that the table is appended to a file named table output April 13, 2023, today's date when I'm making this video, in this folder. I didn't really set a working directory, so it defaulted to this working directory, users berry / documents, and I will pop up that file, the folder, to show you where it's located, and pop up the HTML file to show you what that HTML format version of this table looks like. And that can be pretty convenient if you want to include a table in a presentation or a paper. It's in a little bit of the formatting for you. Now I'd like to show you how you can use the describeC function to generate just the table of descriptive statistics for two variables or more than two variables at the same time. Just starting with the describeC call I did earlier of the NES address years variable weighted using the WT variable in the data set, and it gives us this table of descriptive statistics. But if I wanted to describe more than one variable at the same time, what I would do is go into the command and set the X argument equal to a list of variables that I want to describe. So I set it equal initially to one variable, and to set it equal to a list of variables, I use a function called list. This is included in base R. In my list, I'll say the first item in the list will be the NES address years variable, and to add another variable from the NES data set, I will type the name, get the $, and I will just go ahead and pick another like agreeFacts, and make sure I have the comma separating the two so I know that there are two items in a list, and run that. And this should give me a table of descriptive statistics with two columns. One that reports descriptive statistics for NES address years, and the other that reports descriptive statistics for NES agreeFacts. And we know that already that the agreeFacts variable will have fewer descriptive statistics reported because it has a lower level of measurement than the address years variable does. Now, let me just talk about that list function a little bit. It's probably the first time that this comes up for you, or the first time pardon me, that you've encountered it. So what's going on here? You can only set an argument in a function equal to one thing at a time. So to demonstrate, let's say I want to set the value of X equal to letters, and letters is an object that already exists in the R world. If I set X equal to letters and take a peek at X, I see that it's a vector length 26, which is the lower and has the lowercase letters of the alphabet. Now, what if I want to look at the uppercase letters and lowercase letters at the same time? If I try this, X equals letters, comma letters, I'm going to throw an error now when I try to run this. X cannot be these two things at the same time. If I want to work with them at the same time, I need to use some kind of data structure that assembles these two vectors into one object. And the list function is appropriate for that. So if I use the list function, and in parentheses, I list the things that I want to be listed. So I'll say list, parentheses, letters, comma, uppercase letters, close parentheses. And running this is a valid call. And if I peek at the X object, I see that it's has two items. The first is a vector length 26 of lowercase letters. The second item in the list is a vector also length 26 of the uppercase letters. And this usage of list satisfies the requirement that X can only be set equal to the value of one object at a time. And we'll see a few of these kind of utility type commands to organize information into objects and create different structures of data. One you've already seen is the concatenate function, C. Now take a look at this. If I run X equals concatenate letters and letters, get a slightly different data structure. So it's a vector length 52, and it is the lowercase letters, and then after the vector of lowercase letters, it appends on the end of that the uppercase letters. So it's performing a similar function, but you can see how the result is different, where here I have a vector, one vector of 52 items, whereas the list structure I have two items, and each item in the list is a vector of 26. And you can see if you were to apply different functions to this X object concatenated, you could get some different results, because R is, we process this, is 52 two item vector, like 50, akin to 52 observations, whereas a list, it will look at it as two different items, both of length 26. So that's how we describe two variables at the same time, using this very interesting and incredibly useful utility function in R called list. And you can use a function here like list inside a function. So I'm calling a function describeC, and then one of the arguments of the function is in turn a function list. And the list function is putting these two things together, address years and agree facts, so I can successfully analyze them at the same time with the describeC function.